Good day, everyone. Welcome back to Math 10 Combined. Today's lesson is part 1 of section 2.2 from the measurement unit. In the next lesson, we'll cover the last part of lesson 2.2. Lesson 2.2 deals with what we call surface area of three-dimensional objects. Once we're done with these 2 lessons on surface area, we're going to then spend 2 lessons working with volume, and then we'll be done the unit and we can spend a day or so preparing for the unit exam. So what we're looking at doing today is calculating surface area of solid objects, of three-dimensional objects. But I'm going to start by reviewing how to find area of some very basic two-dimensional shapes. For example, you should know how to find the area of a circle. And I give you this formula on your formula sheet. The area of a circle is pi r squared. And of course, the radius is the distance from the center of the circle to any point on the circle. If you're ever given the diameter in a problem, then you have to remember to divide that diameter by 2 if you want to use this formula. Another very common shape is a rectangle, and the formula for the area of a rectangle is length times width. That's what a rectangle looks like. Both of these formulas are on your formula sheet. The next shape is a square, and I do not give you the formula on your formula sheet for the area of a square. My thinking is you should know that a square is a rectangle. A square is a type of rectangle. It's just that the length and the width of a square happen to be equal. And we usually call those lengths and widths of squares the letter S. It stands for side length. And if I take length times width, that's S times S, which is S squared. That's the area of a square. I do give you the formula for the area of a triangle on your formula sheet. The area of a triangle is A equals 1/2 times the base times the height. The height, of course, is the perpendicular distance from the base to the opposite vertex of the triangle. So why am I going through two-dimensional shapes and their areas if we're talking about three-dimensional objects? The reason is sometimes what you have to do is deconstruct a three-dimensional shape into two-dimensional areas. So you were asked to find the surface area of this box. And we can call it a box if we like, but it's referred to mathematically as a rectangular prism. And I have one here. That's what we're looking at. So how do we find the surface area, which means the area of all of the faces? You need to recognize that if you take a look at the front of this, it's a rectangle. Let me turn it so that we're looking almost dead on it. That is a rectangle, but if you take a look now at the back of it, it is an identical rectangle. So the front and the back of this are rectangular, which means we can find their areas. And furthermore, they're the same areas. If I take a look at the top of this rectangular prism, that's this light colored shape. It's a rectangle, so if we know the dimensions, we can find the area. And we should know enough that since it's a box or a rectangular prism, the bottom is the same. If we look at the left-hand side of this, that's this small rectangle, and the right-hand side of it, it's an identical small rectangle. So how do we find the surface area of this shape? We find the area of the left and double it to get the area of the right included. We find the area of the front and double it to include the area of the back. We find the area of the top and double it to include the area of the bottom. It's very useful for us when we do this to recognize that this 6 inches is 6 inches there and 6 inches there. The 8 inches is 8 inches across the top edge and across the top back edge. The 9 inches is the depth everywhere. And that will give you a little bit of a better handling of looking at the rectangle. So let's find the area. We'll go with top and bottom first. Well, the area of the top, that's this face right here. I don't think most of you need this pointed out to you, but I'm going to shade it in. This is what I'm talking about when I say the area of the top. It's a rectangle that is 9 by 8, so we're going to take 9 inches by 8 inches, and then we're going to double it so that we get the area of the top and the bottom. And this works out to 144 square inches. Let's find now the area of the front. You can do these in any particular order. The area of the front and the back will be equal to, so again, I'm just going to highlight the front so you know what I'm talking about. This is the front face. So that is a rectangle that is 8 inches by 6 inches. And then we multiply by 2 to include the back. And this works out to 48 times 2 is 96 square inches. Now what we're going to do is worry about the area of the right and the left. The right-hand side is a rectangle that is 9 by 6. So the area of the right and left equals 9 times 6 times 2, which is 54 times 2, which is 108 inches squared. So how is it we find the total surface area? The total surface area is going to be found by adding 144 square inches, 96 square inches, and 108 square inches. So 144 plus 96 plus 108 gives me 348 square inches. I know these numbers are right. I'm confident in that, but you can check them with a calculator if you like. So that is our answer, 348 square inches. Let's look at B. So this is what we're looking at here. I'm just going to spin it around so you can kind of visualize what's going on here. The bottom, which is this piece in here that's kind of blocked, I'll just tip it up so you can see it. The bottom is a rectangle. And then it's got 4 triangular faces. Because this length where the hand is different than this length on our example, this triangle is different than this triangle. The triangle you're seeing on the right is different than the triangle on the front. But because the base is a rectangle, this triangle on the front, I'll just tip this now, this triangle on the front, which is here now, and this triangle on the back are identical triangles. Because this length that I'm indicating for the base of this back triangle and this length that I'm indicating for the base of the front triangle, these two lengths are equal, so these two triangles are equal. These two lengths are different than these two lengths, but these two lengths are equal to each other. So what we're talking about is the right-hand face of this pyramid, this triangle I'm indicating here, is identical to the face that's behind on the left, and the face in front is identical to the face that's behind on the right. And then the bottom, of course, is a rectangle. So how are we going to find the total area? Well, we can find the area of the base. That's child's play. The area of the base is the area of a rectangle, which is length times width, which is 20 times 16, which gives me 320 square inches. Nope, square centimeters. Now, what about the area of the front and back triangles? Well, the area of the front triangle, let me highlight this. The front triangle is this triangle. So it has a base of 20 and an altitude or a height of 7 centimeters. I'm just going to put this formula off on the side. The area of a triangle is 1/2 the base times the height. So the area of the front and the back will be 1/2 times the base, which is 20, times the height, which is 17, times 2, because I want to include the front and the back. And I'll just show you how I'm going to handle that in my calculator. I'm just going to treat 1/2 as 0.5, so 0.5 times 20 times 17 times 2 gives me 340 square centimeters. Now what I need to do is I need to find the area of the right-hand side, and I also need to find the area of the left-hand side. Well, they will be equal, so I'm going to find the area of the right-hand side and double it for the right and left. What am I finding here? I'll just indicate it to you. I am finding the area of this side of the pyramid, and that is the area of the right, but I'm going to double it because there's an identical face on the left. So this is the area of right and left. It's a triangle on the right, so that's 1/2 times the base. The base is 16, times the height of that triangle is 18. And then I multiply by 2 because I want to include the other side as well, the left-hand side as well. 0.5 multiplied by 16 multiplied by 18 multiplied by 2. So I'm getting 288. Square centimeters. So just to review here, the area of the bottom is length times width because it's a rectangle and I get 320. The area of the front is 1/2 times the base times the height, and I double that to get 340 because I want to include the back. The area of the right is 1/2 the base times the height, so that's 1/2 times 16 times 18, and then I double it because I want to include the left. My total surface area is found by adding all of these pieces together. I need to add 320, 340, and 288. Total surface area is 340 plus 320. The order doesn't matter, plus 288. I want to say that's 948. I'll check it in my calculator. This is centimeters squared. $320 plus 340 plus 288. Yep, 948 square centimeters. Let's take a look now at what happens if we can't deconstruct the shape into familiar shapes. Well, it just turns out that a sphere, a billiard ball, a basketball, a ball, has a surface area equal to 4 pi r squared. And this is a formula given on your formula sheet. So, example 2. The Earth has a diameter of 1.27 multiplied by 10 to the 7 meters. What's the surface area? First of all, this is the diameter. So the radius, which is what we need because it's A equals 4 pi r squared. The radius is that diameter divided by 2. Now, this is a little awkward for me because I'm not standing there next to you or sitting there next to you and I can't see your calculator, but it's very important that when you enter in high school math or science, a number that's in scientific notation, you do not enter the following. If you just look at your screen, you do not go 1.27, hit the multiplication key, and then go times 10 raised to the 7. Don't do this. Every calculator has an exponential notation key. On mine, it is the second function of the comma. You can't really see it very well, but there's an EE there. When I hit the second key, which is the blue key, I access that, and that's exponential notation. So let me get rid of this now and show you what we would enter here. We would take 1.27, then you go second comma on a graphing calculator, and an E pops up, and it just means exponential notation, and then you enter 7. And it doesn't look like 1.27 times 10 to the 7 on my calculator. On some calculators it will, but you have to use that notation. So now I divide this by 2, and I get this number, 6350 with 3 more zeros. So that's the radius. 6350000. And that's the number I'm going to use in here, 4 pi times 6.35. I guess I won't use scientific notation here. I'll just write it out. 6350000 squared. Don't forget to square that. That's important. If it weren't important, it wouldn't be in the formula. So luckily this number is still on my calculator. I can just take 4 times pi times my answer squared. Now if you have trouble navigating your calculator, that's what I'm there to help you with in class. So if you're in class working on this while you're watching the video, you have to make sure that you can use your calculator properly. Anyway, I hit enter, and I get I'm going to round it to 5.1 times 10 to the 14 square meters, because this was in meters. So there's that E, which means times 10 to, the area is 5.1, E means times 10 raised to the 14 square meters. Let's take a look at before we get to number 3, a cone. A cone has a surface area of pi r squared plus pi rs. The pi r squared is for the base of the cone because it's a circular cone, and the pi rs is what's called the lateral area, which is the area around the side. S in this formula is called the slant height, and it's the distance from the bottom of the cone along the slope of the cone up to the top. R is the radius of the cone's base, and H is the inside height of the cone. I don't know that you really need to see this visualized. I think we've all seen a cone, whether it's an ice cream cone. I'll go with this one. No. I'm going to go with this one. So we can see the bottom of the cone is a circle, and if I rotate this cone, you can see that what I'm talking about for the lateral area is all of the surface area along the side of the cone. All right, so now that we know the formula for the surface area of a right circular cone, we can go ahead and use it. The area of this cone will be pi r squared, which is the area of the base, plus pi rs, which is the area of the side. The only thing we need to remember, of course, is the radius will be 27 divided by 2, which is 13.5 centimeters. Otherwise, it's a pretty straightforward problem. The area will be pi r squared, which is pi times 13.5 squared, plus pi times 13.5 times the slant height, S, which is 40. That's it. Throw it into your calculator, figure out what you get. pi times 13.5 squared plus pi times 13.5 times 40. Pi times the radius squared plus pi times the radius times the slant height. That's it. 2,269 square centimeters. We have one more shape that I want to talk about today, and then we'll finish it off with two quick examples. We're talking here now about a cylinder, and the surface area of a cylinder is found by taking 2 pi r squared plus 2 pi rh. By the way, going back, this formula will be on a formula sheet for you. It's on your formula sheet, and so will this one. Much like the previous formula, this has two pieces to it. One is the area of the bases, and one is the area of the side, the lateral area. So if I take a look at a cylinder, this is a cylinder. If I want the surface area, let's say I'm going to paint this and I need to know how much paint. We've got a lid to this and we've got a base to this. Maybe it's like a soup can. And the area of the top is pi r squared. The area of the bottom is pi r squared. That's why in this formula we have 2 pi r squared. This is the top and the bottom. The lateral area is the area around the outside, which I'll just show you here. That's with the lid removed. And really, if we were to slice this thing, just take a pair of scissors and cut this right here and unravel it, we would have a rectangle. And the length of the rectangle would be the circumference of this, which is 2 pi r, and the width would be the height. So if you're interested in where this 2 pi rh comes from, that's where it comes from. Number 4, what is the surface area of the cylinder? This is child's play because you have the formula and you have all of the information. This is the height, and this is the radius. That's it. Well, I mean, that's not it. We've got to use our calculator. We've got to write a few things down. 2 pi r squared plus 2 pi rh. And we put the numbers in. 2 pi times 4.2 squared. This will be the area of the top and the bottom. Plus 2 pi times 4.2 times 10. This will be the area of the wrapping around the top and the bottom. So 2 pi r squared plus 2 pi rh, that's it. Calculator time. Double check to make sure I've entered everything correct. 2 pi r squared plus 2 pi rh. Done. 375 square centimeters. All right, number 5, we want to find or calculate the exposed surface area of the silo. So maybe somebody is going to be painting this silo. A cylinder, of course, has a top and a bottom and the lateral side, but for this cylinder, we're not going to worry about the top and the bottom because they're not exposed. In other words, if I go to my cylinder, we're painting this. We're painting all around the outside, but we're not painting the top and we're not painting the bottom because they're not exposed. So we don't care about the surface area. Similarly, you would want to paint the top of this, but for a cone, there's two kind of faces. One of the faces is this exposed face, but the other face is the bottom. And we're not going to worry about painting the bottom. We're not going to worry about the surface area of the bottom because it's not exposed. We're only going to be worrying about the lateral surface area. So here's a silo. Bottom line is we're going to be having to find the area of the side of this cylinder, not the top or the bottom. The top is covered up. The bottom, there's the bottom, but it's facing the ground, so we don't care about it. And you're going to have to find the area of the top of the cone as well, but not the bottom of the cone. So let's break this down now. For the cone, the area is pi r squared plus pi rs. However, we are not going to worry about the pi r squared because that's the bottom of the cone. For the cylinder, area is 2 pi r squared plus 2 pi rh. That's from your formula sheet, but we're not going to worry about the 2 pi r squared, which is the top and the bottom. So what do we know here? Do we know r for the cone? I'm going to make a little table here. Cone. Do we know r for the cone? Well, we just have to take 19 feet and divide by 2. That's pretty easy. So that's 9.5 feet. Do we know the slant height? No, we do not. We don't know the slant height, which is this height I'm going to indicate in, I'll say purple or magenta. This is the slant height. Now, we don't know that, but we can find it using the Pythagorean theorem. That slant height is a hypotenuse of a right angle triangle. It's pretty easy to see that the height of the cone is 4 feet. Why? Because 25 minus 21 is 4. The total height from the bottom to the peak of the silo is 25 feet, and the height to the top of the cylinder is only 21, so it's an additional 4 feet. This is 9.5 feet. We've already figured out what that is. So this slant height is the hypotenuse of that triangle. And the Pythagorean theorem says hypotenuse squared equals other squared plus other squared. So we simply have to calculate this and take the square root, and we will have s for the cone. S squared equals 4 squared plus 9.5 squared. And I take the square root, so that's 106.25. So S will equal the square root of 106.25. So the square root of this number gives me about 10.31. So this is for the cone. For the cylinder, I don't think we have any calculations to do for the cylinder. The cylinder has a radius of 9.5 feet and a height of 21 feet. I mean, take a look at the diagram, take a look at the height of the cylinder. It's only 21 feet. Refer you to the top of the page here where we said we're just going to be using pi rs. We're just going to be using pi rs for the cone part, and we're simply going to be using 2 pi rh for the cylinder part. So the area is pi rs. I'll just highlight this for you. Pi times the radius times s, which is 10.31, plus 2 pi RH. A lot of numbers floating around. I'm just going to double check everything. Slant height is 10.31, so pi RS for the cone part. That looks okay. And then, geez, I hope half of 19 is 9.5. Yes, it is. And then 2 pi RH, 2 pi times 9.5 times 21 for the cylinder. That's fine. Now we can finish off this example. Pi multiplied by 9.5 multiplied by 10.31. Well, I might as well just multiply by this. Correct that a bit. There we go. Pi times 9.5 times that whole answer plus 2 times pi times 9.5 times 21. Like I said, a lot of numbers. Pi RS plus 2 pi RH. Looks okay. So the total surface area in feet is 1,561 square feet. And that's our answer. That's it. On page 74, 1, 2, 5, 10, and 12 are your practice problems. In the meantime, and in between time, take care of yourselves, and I hope to see you soon. Talk to you later.